So let's say you're trying to find the TPL, and this question right here says, find the TPL in 400 feet of 2.5-inch hose equipped with 1-inch tip flowing 65 psi. So this is a whole bunch of jargon to say we just need to find what the TPL is. So we're going to take it one step at a time, and we're going to find out what is your TPL. So to start, let's see, we need to know what the formula is for TPL. And TPL equals your friction loss plus your elevation loss, okay? And in the prior video, we went over some problems with friction loss. So if you need to figure out how to do friction loss, you can go to that video, but we're also going to break it down here too. So we need to find TPL in 400 feet of 2.5-inch hose equipped with 1-inch flowing 65 psi. Notice how this question doesn't say anything with elevation, okay? So we already know right off the bat, if it's not asking for elevation, we can get the elevation loss out of the way. So now, all we're trying to find out is friction loss. So what did we say friction loss was? Well, friction loss equals your coefficient times your GPM over 100 squared times your hose length. But it's your hose length divided by 100, okay? So, to start, for our friction loss, we know that we're working with we'll go over here. We know that we're working with a 2.5-inch hose. We know that based off that chart that our 2.5-inch hose equals 2 as the coefficient, okay? So we're going to use that coefficient because it equates to the diameter of the hose, and each diameter has different coefficients associated with it. So we take our 2 multiplied by our GPMs over 100. Now, the problem says that, find the TPL in 400 feet of 2.5-inch hose equipped with 1-inch tip following 65 psi. It gives us nothing about our GPMs. So then we're like, wait, well, how do we know what our GPMs is so we can solve the question? Well, there's actually an equation for that. And in order to find our GPMs, GPM, that's going to be the formula of 29.7 times the diameter of the hose squared times the square root of our nozzle pressure. So let's kind of break this down. When we're talking about nozzle pressure, I just want you to think about pressure. when you think about pressure, PSI is your pressure per square inch. So when we're trying to find the nozzle pressure, right, we need to find what the PSI is. And we know in the equation, it said TPL in 400 feet of 2.5-inch hose with a 1-inch tip following 65 PSI. So we know our PSI is 65. And when we talk about the diameter, we're not talking about the diameter of the hose. We're talking about, what is it? That, or I believe he said not the diameter of the nozzle, or not the diameter of the hose, but we're talking about the diameter of the nozzle. I'm sorry if that's confusing. So we already know that 2.5-inch hose, that goes with the coefficient. And so whatever the tip is, that 1-inch tip, that's going to be the diameter that we need to square. So our diameter is going to be that 1-inch tip times 29.7. And so in order to find GPMs, our gallons per minute, we need to do 29.7 times 1 squared times our nozzle pressure, which we found was 65. So it's going to be the square root of 65. We know that 1 multiplied by itself is going to equal 1. But to figure this problem out, we would like to go ahead and figure out what the square root of 65 is first. So we'll go over to our calculator. Square root of 65 is going to give us 8.0622577748. We don't need all those numbers. You probably just need the first 3. That's it. So 8.06. So we know now that our nozzle pressure is 8.06 times, we're working backwards right now, the diameter, which we said was that 1-inch tip, it's going to be 1 squared. 1 times 1, we can go over here. 1 times 1. It's going to give us our 1 times our constant for here, which was 29.7. Now, in order to find GPM, we just multiply all of those together. So it's going to be your 29.7 times 1 times 8.06 is going to give us a GPM of 239.38. And remember, you don't need to use all the other numbers that come with it. It was like 239.382. We're just doing with the last 2 decimals. But you can even go with just 1 decimal over if you wanted to, or you could deal with whole numbers. your answer might differ a little bit, but you should get fairly close to what you're looking for. So, out of all of this, right, we found out what our GPM is. Now, we're going back to the original problem where it says, in order to get our flow rate, we need to know what our coefficient times our GPM over 100 squared times our length divided by 100 is. So, going back to the original problem, we know that we're dealing with a 2.5-inch hose line, which gives us a coefficient of 2. We plug that in right there. We just found out that our GPM is 239.38. So we go up here, 239.38 divided by 100. Because remember, we're still trying to figure out Q. And Q is your GPM over 100. That's why it's over 100. Times the length of our hose, which it told us the length is 400 feet of hose, over 100. And why does it have to be over 100? It's because our length equals our length of our hose divided by 100. And so we're just taking that formula and we're plugging it in right here. So we're going to take this and we're just going to come all the way down right here. Okay, so that way we have enough space. So friction loss equals your coefficient, which is 2, times your GPM, which we figured out the GPM right here was 239.38, and we're going to divide it over 100 because that's what the formula up here is making us do to get to Q. So 239.38 divided by 100, 239.38 divided by 100 gives us 2.3938. Again, we probably just need 2.39. That can work perfectly fine. So we did our GPMs divided by 100, which gave us 2.39. Now remember, right? It wants, for friction loss, the formula for friction loss is Q squared. So we want to come back down here and we want to make sure that we're putting our square. Sometimes to keep it neat, I'll put it in parentheses, so that way it's away from everything else. Multiplied by the length of the hose divided by 100, so 400 divided by 100. So go over here to our calculator. 400 divided by 100 gives you 4. So we know the length of our hose is 4. Now remember with PEMDAS, if you don't know what PEMDAS is, okay, it's your parentheses, exponents, multiplication, division, addition, and subtraction from left to right. We do what's in the parentheses first, and then we do our exponents, and then we just kind of multiply from left to right, okay? We kind of jumped the gun with, the 4, but that's okay. 2, which is our coefficient, times 2.39 squared. So anything that's squared is just multiplied by itself. So if we had it to, let's say, the fifth power, it'd be 2.39 times 2.39 times 2.39 times 2.39 times 2.39, okay? But it's just asking for it squared. So that's just going to be 2.39 times 2.39. 5.7121, so just 5.71. So 5.71, that's how we squared it. Now we got our GPMs, times the length of our hose, which is 4. So now to get the flow rate, we're going to multiply all of this together. So we've got 2 times 5.71 times 4, and that's going to give us our flow rate, which is 45.68. So our flow rate equals 45.68. Now, we're not done just yet, okay? We want to make sure that we're doing everything that we're supposed to do with this equation. So what did it ask for? It wanted the TPL. And it gave us 400 feet, 2.5 inch hose, 1 inch tip, 65 PSI. It didn't give us anything else. If it did give us elevation, that's when we would need to find our elevation. However, it didn't give us that, okay? So we're gonna do TPL equals, we found out our friction loss, 45.68 plus our elevation loss. We said that our elevation loss is not in there, so we don't need to worry about it. But other questions might ask or might state that there's some type of elevation loss, so that's what we're going to want to do. So your TPL equals 45.68. That's your answer.